Hello, Dan Nadelkowski here from howtomechatronics.com. In this Arduino tutorial, we will learn how to control DC motors using Arduino. We will take a look at some basic techniques for controlling DC motors and make two examples through which we will learn how to control DC motors using the L298N driver and the Arduino board. At the end, we will be able to build and control our own Arduino robot car. We can control the speed of a DC motor by simply controlling the input voltage to the motor, and the most common method of doing that is by using PWM signal. PWM or pulse width modulation is a technique which allows us to adjust the average value of the voltage that's going to the electric device by turning on and off the power at a fast rate. The average voltage depends on the duty cycle or the amount of time the signal is on versus the amount of time the signal is off in a single period of time. So, depending on the size of the motor, we can simply connect an Arduino PWM output to the base of a transistor or a gate of a MOSFET and control the speed of the motor by controlling the PWM output. The low power Arduino PWM signal switches on and off the gate at the MOSFET through which the high power motor is driven. On the other hand, for controlling the rotation direction, we just need to inverse the direction of the current flow through the motor, and the most common method of doing that is by using an H-bridge. An H-bridge circuit contains four switching elements, transistors or MOSFETs, with the motor at the center forming an H-like configuration. By activating two particular switches at the same time, we can change the direction of the current flow, thus change the rotation direction of the motor. So, if we combine these two methods, the PWM and the H-bridge, we can have a complete control over the DC motor. There are many DC motor drivers that have these features, and the L298N is one of them. The L298N is a dual H-bridge motor driver which allows speed and direction control of two DC motors at the same time. The module can drive DC motors that have voltages between 5 and 35 volts with peak currents up to 2 amps. Let's take a closer look at the pinout of the L298N module and explain how it works. The module has two screw terminal blocks for the motor A and B and another screw terminal block for the ground pin, the VCC for the motor, and a 5V pin, which can either be an input or output. This depends on the voltage used at the motor VCC. The module have an onboard 5V regulator, which is either enabled or disabled using a jumper. If the motor supply voltage is up to 12 volts, we can enable the 5V regulator and the 5V pin can be used as output, for example for powering our Arduino board. But if the motor voltage is greater than 12 volts, we must disconnect the jumper because these voltages will cause damage to the onboard 5V regulator. In this case, the 5V pin will be used as input, as we need to connect it to a 5V power supply in order the IC to work properly. We can note here that the IC makes a voltage drop of about 2 volts. So, for example, if we use a 12V power supply, the voltage at the motor's terminal will be about 10 volts, which means that we won't be able to get the maximum speed out of our 12V DC motor. Next are the logic control inputs. The enable A and enable B pins are used for enabling and controlling the speed of the motor. If a jumper is present on this pin, the motor will be enabled and work at maximum speed. And if we remove the jumper, we can connect a PWM input to this pin and in that way control the speed of the motor. If we connect this pin to a ground, the motor will be disabled. Next, the input 1 and input 2 pins are used for controlling the rotation direction of the motor A, and the inputs 3 and 4 for the motor B. Using these pins, we actually control the switches of the H-bridge inside the L298N IC. If input 1 is low and input 2 is high, the motor will move forward, and vice versa. If the input 1 is high and input 2 is low, the motor will move backward. In case both inputs are the same, either low or high, the motor will stop. The same applies for the inputs 3 and 4 and the motor B. Now let's make some practical applications. In the first example, we will control the speed of a motor using a potentiometer and change the rotation direction using a push button. Here's the circuit schematic. So we need an L298N driver, a DC motor, a potentiometer, a push button and an Arduino board. Here's the Arduino code. So first we need to define the pins and some variables needed for the program. In the setup section, we need to set the pin modes and set the initial rotation direction of the motor. In the loop section, we start by reading the potentiometer value and then map the value that we get from it, which is from 0 to 1023, to a value from 0 to 255 for the PWM signal, or that's 0 to 100% duty cycle of the PWM signal. Then, using the analog write function, we send the PWM signal to the enable pin of the L298N board, which actually drives the motor. Next, we check whether we have pressed the button, and if that's true, we will change the rotation direction of the motor by setting the input 1 and input 2 states inversely. The push button will work as toggle button, and each time we press it, it will change the rotation direction of the motor. So once we have learned this, now we can build our own Arduino robot car. Here's the circuit schematic. All we need is two DC motors, the L298N driver, an Arduino board and a joystick for the control. As for the power supply, I chose to use three 3.7 volt lithium batteries, providing total of 11 volts. I made the chassis out of 3 mm thick plywood, attached the motors to it using metal brackets, attached wheels to the motors, and in front attached a swivel wheel. Now let's take a look at the Arduino code and see how it works. After defining the pins in the loop section, we start with reading the joystick X and Y axis values. The joystick is actually made of two potentiometers, which are connected to the analog inputs of the Arduino, and they have values from 0 to 1023. When the joystick stays in its center position, the value of both potentiometers, or the axis, is around 512. We will add a little tolerance and consider the values from 470 to 550 as center. So if we move the y-axis of the joystick backward and the value goes below 470, we will set the two motors' rotation directions to backward using the 4 input pins. Then we will convert the declining values from 470 to 0 into increasing PWM values from 0 to 255, which is actually the speed of the motor. Similar, if we move the y-axis of the joystick forward and the value goes above 550, we will set the motors to move forward and convert the readings from 550 to 1023 into PWM values from 0 to 255. If the joystick stays in its center position, the motor speed will be 0. Next, let's see how we use the x-axis for the left and right control of the car. So again, first we need to convert the x-axis readings into speed values from 0 to 255. For moving left, we use this value to decrease the left motor speed and increase the right motor speed. Here, because of the arithmetic functions, we also use two additional if statements to confine the range of the motor speed from 0 to 255. The same method is used for moving the car to the right. Depending on the applied voltage and the motor itself, at lower speeds the motor is not able to start moving and it produces a buzzing sound. In my case, the motors were not able to move if the value of the PWM signal was below 70. Therefore, using these two if statements, I actually confined the speed range from 70 to 255. At the end, we just send the final motor speeds or PWM signal to the enable pins of the L298N driver. So that would be all for this tutorial, and in my next video we will upgrade this Arduino robot car by adding a Bluetooth and radio devices for enabling smartphone and wireless control. Thanks for watching, and for more tutorials and projects visit howtomechatronics.com.